Okay, this is section 9.1, translating figures using vectors. Okay, so vectors are probably a new thing for most of you, but it kind of piggybacks off an old thing. When we talked about translations, when we talked about rotations and flips and just movements, right? Translations, these transformations. Okay, so if we kind of think back, this first part is a review, and then we'll kind of kick into the new stuff a little bit later. So the first thing is an image. The image, if you think back to Geometry A, is the new figure formed after making a translation of the original figure. So after making a translation of the original figure. Now the name for the original figure is called the pre-image. So we have the image and the pre-image. These things are obviously very closely related. The pre-image is what we start with, the image is what we end with. We call that a translation moves or maps. We call this a mapping. It maps every point of a figure the same distance in the same direction. So we're going the same distance and the same direction. Okay? And so let's take kind of just an example real quick. If we think back to Geometry A, if we start with line segment AB, and I want to translate that thing maybe over here, okay, to its new place, the same distance in the same direction, and the image is going to be labeled, we're going to call it A prime, B prime, right? So that is called prime notation, and it's read as A prime. Okay, it's read as A prime and B prime. It's called image notation. Okay, so when we actually do the mapping, that's what we're talking about. Is taking, it could be a segment, it could be a polygon. We're going to move it into a new position, and that new position is called the image of the figure. Yeah, I also want to talk about an isometry. An isometry is a transformation that preserves length and angle measures. So all we're simply talking about is, for instance, this transformation that we did here is an isometry, but we want to preserve length and angle measure. Okay, so if we shift it and we keep the same length and we keep the same angle measure, for instance, the next example down here, we're looking at a triangle. We keep the same angles in that triangle, and all the lengths are the same. We move all points in the same way. Then we've got an isometry. Okay, let's do a translation on this triangle. If we think back once again to Geometry A, this is called coordinate notation right here. Okay, so that's coordinate notation. And all this means that we're going to take every x-coordinate and add 4 to it. And we're going to take every y-coordinate and we're going to add 3 to it. Okay, so over here in my triangle, I've got 3 points, and I'm going to add 4 to all the x's, add 3 to all the y's. Okay? Okay, so all I've done is written down the points A, B, and C there, and their coordinates. And I'm going to take, and for A prime, which is the new point, I'm going to add 4 to the x-coordinates. Negative 3 plus 4 is going to give me 1. And then 2, I'm going to add 3 to it, so that's going to be 1, 5. Okay, we're going to keep doing this. B prime is going to be negative 2 plus 4 is 2. Negative 2 plus 3 is 1. And C prime, 2 plus 4 is 6. And negative 2 plus 3 is 1. Okay, so 6, 1. And those are my 3 points. And now what I'm going to do is graph those and see where this thing ends up. Okay, so A prime is at 1, 5. So we over 1, up 5. That's A prime. B prime is at 2, 1, over 2, up 1. That's B prime. And C prime is at 6, 1, over 6, up 1. That's C prime. I'm going to connect the dots here. And that's my new figure. And you can see what we've done is we've taken and we've moved, we've taken the original figure, the pre-image, and we've moved it in the same angle, in the same direction, and kept all the same lengths. So this is an isometry, and this would be the pre-image down here, and this up here would be the image. Okay, and we said that an isometry preserves length and angle measure, and that this example is an isometry. So this is an isometry. That's a new vocab word that you're going to want to kind of get down. an isometry. So we're going to move on to theorem 9.1 that says that a translation is an isometry. Okay, so what we did up here in this example is a translation. It's an isometry. That's all the theorem says. So if I kind of, in this example here, I'll draw an arrow here, I guess, I'm saying that triangle ABC is congruent to triangle A prime, B prime, C prime. Okay, that's basically what it means. In isometry, I've got congruent triangles. The angles are the same, the side lengths are the same, and that's all theorem 9.1 says, is that that a translation is an isometry. And literally, like I wrote down here, this simply means that if you translate a figure, the image and the pre-image are congruent. The image and the pre-image are congruent. Okay, so now we're going to start talking about vectors. What's your vector? Victor. So this is kind of the introduction to vectors. All right, now vectors are rays. Okay, so let's kind of list a couple things that we know. Vectors are rays. Okay, so you might write that right next to the big bold vectors up there on your paper. And here's a real life problem, kind of where a vector comes in handy, and hopefully it's a kind of a good introduction to vectors as well. Let's say you're in a boat. Okay, so you are in this boat right here, and you're trying to get to the other side of a river. This purple thing here, this is the river, and you want to get to the other side of it. You're starting over here on the left, you want to get to the right. The problem is that you've got a current, a 3-mile-an-hour current going in this direction, right? So you've got all this force of the water moving and pushing you in your boat. You start off going, and it doesn't really matter how fast you're going, but the bottom line is that you start here at point, we'll call it point P, okay? And you end up down here at point P prime. And what's important is that this is where you start. This is the beginning. This is the initial point that you begin. In fact, we're going to call that point P is the initial point. Point P is the initial point. Okay? Now where you end is where your line, your distance, your traveling, your route, whatever, where it terminates, where it ends, is going to be down here at P prime. That's called the terminal point. Okay, so that's your terminal point. Okay, so components have a couple things. One, they have an initial, vectors have a couple things. They have an initial point, and they have a terminal point. This is where it starts at P, this is where it ends is at P prime. Okay, so that's kind of the structure of the beginning and ending of where you start and where you land on the other side of the river. Okay, another important thing about vectors is that they're made up of two components. Okay, so vectors are arrays, and they also have two components, or pieces. Okay, so I guess let's title this vectors. I don't know if you want to put this somewhere in your notes maybe. They're rays, and they have two components. They have a horizontal component. In fact, let's choose a different color here. Let's choose, how about green? They have a horizontal component. And they also have a vertical component. So right, this here, 18 meters, is the horizontal component, and this over here would be the vertical component, 22 meters. Okay, so we've got the up and down, and we've got the horizontal and the vertical, which is the up and down. Okay? So there's the different pieces of the vector. And when we write the vector, the component form of vector, if you look over to that box to the right in your notes, component form of vector, we're going to use the horizontal and vertical components of the vector. Okay, so our horizontal, once again, is 18, and our vertical is 22. So if we wanted to write, kind of the name of this vector, if we wanted to name P prime, which is our kind of route or distance across the river, if we wanted to name it, we would write this P prime, and it starts off writing it just kind of like we would a line maybe, okay, or a array, P prime. And then we use this special notation, these kind of bracket-looking things here. They look like kind of like a big grading sign. But anyway, So we use that symbol. 18 is our x component, right? So that's where that comes from. And then 22 is our vertical component. Okay? And so that's how we would write the component form of that vector. Now there's one little thing. Vectors have direction. Okay? And this direction is going down. Alright? So even though the length here is 22, since it's going down the river, we've got a positive 18, and we've got a negative 22, okay? So this is going to be 18, negative 22, because we're going right 18 and down 22 units, okay? So I know it's a lot of stuff about vectors here in the beginning, but we're going to kind of work with them and hopefully clear some of the confusion up, because I know this is a new subject for you guys. Okay, so let's, in these examples, these two examples right below that box, let's look at how to name these vectors, okay? So let's look at the name of vector. Obviously, we're going to call it AB, right? It's array, and we name it just like with array. So AB, that's kind of the easy part. And then we've got to look at the components of this vector. All right, so first we name by horizontal and vertical components, just like we would if we're kind of naming a point. Well, you can think about it as naming the x direction first, in the y direction second, okay? This is going to be a positive 1, 2, 3, 4, right? 4 units over, 4, comma, and we're going to go down 1, so 4, negative 1. So we've got 4, negative 1 over here. Over 4, down 1. Alright, let's name the next one. Obviously this is going to be EF, right? Ray EF. And, we're using component form. Vector component form, okay? And so, now this one, we're going to name the x first, or the kind of horizontal component first. We're going to go over 1, 2, 3 units, so that's going to be 3. And then we're going to go down, or up, 0 units. Okay, so this is just going to be 3, 0. We can't forget about that 0, okay, because that tells us something. It tells us to get from E over to F, we go over 3 and up or down 0, okay? And once again, up in here in the first example, to get from A to B, if I were to give you instructions from A to B, I would say go right 4, and then go down 1, okay? So you can think of vectors like that too.